Einstein gave one of the most famous equations in physics, that is E is equal to mc squared, in which he relates energy with mass, where c is the speed of light. But he couldn't explain why do elementary particles, which are the smallest constituent of matter, have mass. This took the journey of mass from macro level to quantum level. Decades later, Peter Higgs came, who explained that all particles don't have inherent mass, rather they gain mass by passing through a field. Interesting, isn't it? Day-to-day life, we talk about things in terms of mass, but how does a mind perceive it? We call those objects which are harder to move and heavier to lift as more mass than those objects which are easier to move and lighter to lift. That's what we call inertia. This is because in Newtonian physics, mass is related to force, but Einstein perceives it in terms of energy in his equation E is equal to mc squared. Now, if we rearrange this equation as m is equal to E by c squared, then it shouts, mass is a property that all energies exhibit. Instead of thinking mass as an amount of matter that the particle contains, rather we can think it as the amount of energy the particle has.
That means these two identical pizza pieces, one hot, other being cold, have different masses.
Well, the hot pizza has some extra thermal energy because it is hot. And as I told you earlier, every form of energy has a property called mass with it, so this will add some extra mass to the hot pizza piece. But yes, thermal energy E compared to c squared is very small, and thus the mass associated with it.
Now let's see what happens at atomic level. If we keep on breaking the pizza pieces, then we will get elementary particles which will have some mass. But how do these particles acquire mass? Even Einstein was clueless.
There came a masterstroke from Peter Higgs, who with his groundbreaking concept of Higgs Field answered it. Well, the main idea behind the Higgs field is that all particles have same mass, that is zero mass, and they gain different masses by interacting with the field differently. So before understanding the concept behind the Higgs field, let's imagine how it looks like. Understanding how do particles interact with Higgs field, we need to imagine how it looks like. Just imagine that all your near surrounding contain this net of badminton racket, 1 upon 1, 1 upon 1, 1 upon 1 everywhere. Yes, Higgs field exists everywhere and there is no way to hide from it.
To understand the interaction of particles with Higgs field, let's take an analogy. Consider iron dust as Higgs field, plastic block as elementary particle 1p1, magnetic block as elementary particle 2p2. Initially they have same mass, that is zero mass. P1 passes easily through iron dust without interacting with it and maintaining its motion, whereas iron dust offers resistance to P2's motion and our mind perceives as increase in mass of magnet. When the elementary particle interact with Higgs field, they gain mass through similar process. Does it mean our 100% mass is because of interaction of elementary particles with Higgs field? Let's find out. Assume E's and Q's to be elementary particles. A proton is made up of such three Q's. Let's call them R, G and B. Here is an interesting thing, the sum of the masses of these individual Q's is much smaller than proton which contains them. Why? Consider these two magnetic bars. We require energy to hold them as they push each other. In a similar fashion, the glue that binds these Q's to make a proton has its own energy, and the relation m is equal to E by c squared answers why proton is more massive than the three individual Q's. Let's go back to pizza piece. Matter is made up of molecules or atoms which consist of electrons or E's and nucleus bound by potential energy. Nucleus further breaks into protons and neutrons bound by binding energy. Proton and neutron made up of quarks or Q's glued together by gluon field energy. Quarks and electrons are examples of elementary particles and they acquire mass through Higgs field. Together they contribute to 1% of total mass. All these energy contribute for the rest 99% of total mass. And that's how every visible thing acquires mass.